my name is Kim Klinko, and I am an OpenSciEd teacher as well as an OpenSciEd facilitator. I know that lesson 4 seems like a lot of materials management, but it is totally worth it. Let me show you why I love this lab so much. In lesson 3, we were trying to figure out which substance in a bath bomb causes the gas bubbles. Students mixed one ingredient at a time in water only to find out that no one substance makes the gas bubbles. And we also figured out some things about substances, that they have properties, and those properties can help identify a substance. This led us to wonder if there's a combination of substances that are causing the gas bubbles. Here's the lesson at a glance. It's a 2-day lesson, and there is an amazing video that shows you the lab setup for day 2. It is completely worth watching as it really helps you visualize what you're supposed to do. I'll be telling you a little bit more about that later as well. On day 1, you'll gather students in a scientist circle to add to their progress tracker. They'll plan for the investigation that happens on day 2 and reflect on some norms. On day 2, students will actually carry out the investigation, take some time to analyze their lab data, and then make an argument for which substances in a bath bomb produce a gas bomb, and more importantly, explain if the gas is a different substance. On day 1, we figured out that properties don't change for a substance, and on day 2, the gas was not something that was there before. We also learned that there's a combination of substances that cause the gas bubbles. This is citric acid, baking soda, and water, and that matter is conserved. So on day 1, we're going to add to our progress tracker. This is actually from lesson 3. You're going to want to gather your students in a scientist circle. You'll want to have your key model ideas poster hanging up as students are able to see the key model ideas so far. That looks something like what you see here on the slide right now. There are 2 parts to the discussion. First, just remembering what we found out about the ingredients, that bath bombs are made of lots of different ingredients and that none of them create the gas bubbles on their own when they mixed with water. Then you're going to shift to capturing the idea that we're going to come back to again and again. This is that properties don't change for a substance. And you'll add this new key idea to your poster. You can see that here at the bottom. After the progress tracker, in part 4, students will plan the investigation for testing 2 substance combinations with water to see if any of those combinations produce gas bubbles. This discussion ends with you presenting the data table you see on the screen here. As you can see, students have crossed out the middle row with X's to note that they will not be testing 2 substances of the same kind in water. For example, they won't be testing coconut oil, and water. Again, that's what they tested in lesson 3 already, so there's no need to replicate that here. So here we are on day 2, part 5, carrying out our investigation. Students are going to actually combine different ingredients depending on which group they're in that you've set up the day before. Take some time to discuss your materials management with students before passing out materials. For example, where do you gather your materials? What do they do in case of a spill, etc.? As students carry out the investigation, please make sure to walk around the room and make sure that they're not cross-contaminating substances. Students might make some interesting observations that may be questionable. For example, the oil already has some bubbles in it when they pour it into the ice cube tray. This is a good observation, and they're going to be talking back and forth about if that is the bubbles they're looking for, or is that something different. Make sure students make note of that and prompt those students to share it at the end when the whole class shares out data. it's a good conversation about what the bubbles actually are and if they're the bubbles we're looking for that they saw in the bath bombs. Students enter their data as Y's or N's into the data table, and you can see here that the only Y's, the only yeses, should be in the citric acid and baking soda combinations. Now, of course, you might have some that are not, and it may be worth repeating those combinations as a whole class demo really quick in front of the students just to confirm that it is in fact only citric acid and baking soda that produces the same kind of gas bubbles we saw in the bath bomb. Also on day 2, in part 8, now that we've tested the substances and we have a really good understanding that the combination for creating gas bubbles is actually baking soda, citric acid, and water, here in part 8, you're going to write a class consensus. So this looks like you leading a whole class discussion and you're scribing what students are saying. You can do this on chart paper. I've also done it electronically. You'll want to have the poster about the parts of an argument from lesson 2 handy. The question students are answering has 2 parts to it. Which substances in a bath bomb produce a gas? And explain if the gas is a different substance. Now that's a big key idea that students gain from this lesson. The claim should look or sound something like, the gas is a new substance that we did not start with. Sometimes it's helpful to use the word, the gas is a different substance that we did not start with, rather than the word new. Some of the evidence that you want students to point to is the difference between what we started with and what we ended with. That we started with 2 solids, citric acid and baking soda, a liquid, water, and then we end up with a gas, the gas bubbles. Here, the reasoning you're looking for, listening for, are substances can be identified using their properties. That key idea that you came up with at the beginning on day 1. The teacher edition also gives you some sample student answers to help guide you in this discussion as well. It is totally worth the time for this investigation to set up. Try not to be overwhelmed by the lab setup. There is this great video again that shows you what the setup should look like. It's very helpful. Be sure to make enough solutions for each section of your class. Of course, the teacher edition will give you certain amounts that you may need to adjust to work with your needs. If possible, it's also helpful to set this lab up the day before because it does take around 35 minutes. You'll also need to label each pipette with the letter that corresponds to the substance. It's really important that students don't cross-contaminate the substances or they might get false positives or negatives here. I find that if you use Sharpie directly on the pipette, sometimes it rubs off, especially when it gets in contact with some of the oils. And so another suggestion or workaround here is to take a piece of tape like masking tape or blue tape and sort of make a flag on the pipette, and then you can write the letter directly on that flag. Also, you'll find that the ice cube trays can be tricky to clean out and need to be cleaned really well in between classes. I find that Dawn soap works the best here, but if you don't have enough time for students to clean the trays and have them cleaned out in between classes, it might be easier to test the 2 oils, the coconut oil and the olive oil, in cups, small plastic cups that can just be tossed out at the end of the investigation for each class. I know it seems pretty wasteful, but it's a great time saver, and it's also easier for students to clean up rather than having to really scrub out those ice cube trays. I also find that you can label the ice cube trays themselves with a little piece of sticky note, like a flag, on the corner of the ice cube slot so that students can keep track of which substance combinations are in which cube. You will on day one, when you set up the lab, also set up what the tray should look like, but that can be a little tricky for students. So this is just an alternative that makes it that much easier for them to notice which substance combination is in which cube. Again, this is totally worth the time, and kids get really good practice at doing real science here. It can be messy, and as we know, there are a lot of materials, but the students really have a lot of fun mixing different things and getting some interesting results. I love watching my kids do this. They really get into it, and I hope that you have fun and enjoy it with your students as well. The only word that will come up during this lesson is the word property. It was introduced in lesson 3 and reinforced here in lesson 4. There are a couple of posters that you'll be using in this lesson. The first one is the key model ideas. That's a poster that you'll come back to throughout the unit, and you'll be adding, again, that last bullet point, properties don't change for a substance. That's on day 1. On day 2, you'll be going back to referencing the argument poster that you made back in lesson 3. So make sure that's up and handy for students to be able to help as you write that class consensus argument. Again, students really enjoy this investigation. It's early in the school year too, and it gets students invested in continuing to figure out what makes the gas bubbles in a bath bomb. Thank you for listening.